SOH CAH TOA, the classic mnemonic device, makes a comeback. Right triangle trigonometry, it seems complicated, but it can be simple. As long as you remember, trig functions are not values, they are ratios, just like fractions or proportions. Let's get that perfect score. Welcome to Perfect Score with Carl Rosenthal, your source for SAT and ACT math preparation. Come for the math tips and stay for the acute kiddies. Get it? I'd like to invite you all to subscribe to my channel. I will be posting targeted math lessons and full section workthroughs weekly. And I also humbly ask you to smash that like button for the YouTube algorithm. When you're dealing with right triangle trigonometry, it helps to focus on these three words: opposite, adjacent, and hypotenuse. These terms refer to the different side lengths of a right triangle. Let's take a look. With this right triangle, let's focus on angle A. When we're talking about angle A, the opposite side is the leg that angle A is not touching, right here. And the adjacent side is the leg that the angle is touching. For our purposes, we define leg as one of the two perpendicular and shorter sides of a right triangle. And hypotenuse, aside from being a big fancy word, describes the longest side of a right triangle, the one that is opposite from the 90-degree angle. Once you're able to quickly identify opposite, adjacent, and hypotenuse, your next step is to learn to love SOH CAH TOA. What is SOH CAH TOA? It's an acronym to help you remember what each trig function actually is comprised of. They're all fractions. Sine is going to be opposite over hypotenuse, or SOH, S-O-H. Cosine is adjacent over hypotenuse, or CAH, C-A-H. And tangent is opposite over adjacent, or T-O-A, TOA. So, our number one rule here will be, as soon as you see that a question is asking about right triangle trigonometry, just write down on the page, SOH CAH TOA. This should be your first step. All right, let's dig in. I have picked 4 right triangle trigonometry questions, 2 from the ACT and 2 from the SAT, and I put them here in order of difficulty, easiest to hardest. Here, because there's 5 options, we know this is from the ACT. This is number 25, probably still pretty easy, but not that easy. Which of the following trigonometric equations is valid for the side measurement x inches, diagonal measurement y inches, and angle measurement w in the rectangle shown below? So first thing, without thinking any further, we write down SOH CAH TOA. And of course, let's just remind ourselves that S is sine, C is cosine, T is tangent. Nowhere in the ACT or the SAT will you be asked to solve for cotangent and secant. So we know B and C, cotangent W, and secant W have to be out. Now, even though this problem gives us a rectangle, all we really care about is this triangle over here. So let's just make it clear that all we're looking at is this right triangle. The reason they told us it's a rectangle is that we know this angle here is right. So let's label what we have. Angle W, we're given this side, which is of course the hypotenuse. It's always opposite the right angle, so let's mark it in. H for hypotenuse, and we're given this over here. Well, it's not touching the angle in question, so therefore it's got to be the opposite. So we're dealing with O and H. Which of these contains O and H? Clearly SOH. This is a sine question. Let's write this down. If sine equals opposite over hypotenuse, well then the sine of W is the opposite side, or x, over the hypotenuse side, or y. Sine W equals x over y, and voila, the answer must be D. We now look at an SAT problem. This is from section 4, the calculator section. Although for our purposes, we will not be using a calculator, but just so you know, a calculator is allowed here. So, in the figure above, sine of 90 minus x equals 12 over 13. What is the value of sine x? Well, let's go ahead and write down what we always write down. SOH CAH TOA. And of course, we know we're dealing with sine, so let's just focus on this and remind ourselves sine of any angle equals OH, opposite over hypotenuse. Well, look at this. They're telling us that the sine of 90 minus x equals 12 over 13. Well, what is 90 minus x? Let's figure this out. If this angle is 90 and this angle is x, perhaps it's this one. Let's find out. For the time being, let's label this angle as y. And we know that x and y, well, they have to add to 90 because all three of these must add to 180. So we'll say x plus y equals 90. And if we solve for y, well then, lo and behold, look at that. Y equals 90 minus x. So they're actually talking about this angle over here. That's 90 minus x. So for our purposes, let's rename this for what it is, which is 90 minus x. These two angles, because they add to 90, are called complementary angles. So now we can work with this. If the sine of 90 minus x is 12 over 13, and the sine is opposite over hypotenuse, well, we can go ahead and label the opposite side and the hypotenuse side 12 and 13. And so we have to now figure out what this missing side is. How can we find the missing side of a right triangle? Well, I'll remind you of the Pythagorean theorem that says a squared plus b squared equals c squared. A and b being legs and c being the hypotenuse of a right triangle. So we know this side is 12. We want to find out this side. Let's call it b. And we know this side is 13. So we're going to say a squared, or 12 squared, plus b squared, b is what we want, equals 13 squared. Now this is where, if you have a calculator, you're allowed to use it. We know that 12 squared is 144, plus b squared, as we're finding out, equals 13 squared. 13 squared is going to be 169. Now we're solving for b. Let's subtract 144 from both sides. B squared is going to equal, that's 5, and that's 2. It's 25. Of course, if you have your calculator, keep using it, because the square root of 25 is going to be 5. B is actually 5. 5 is that missing side. For those of you who see this, this is actually a very famous Pythagorean triple, 5, 12, 13 triangle. Okay, back to the question. What is the value of sine x? Now we're back to this angle. We want to know the sine. Well, the sine is going to be, as we know, the opposite over the hypotenuse. Well, the opposite of x is going to be 5. And the hypotenuse never changes. That's 13. The answer is 5/13. B. Now this question you see is number 52 of the ACT. 52 is one of the hardest questions on the test. It gets harder and harder until number 60. So let's be very careful to read, because it's probably going to be tricky. A camper at Site C sends a distress signal. The signal is received by both Ranger Station A and Ranger Station B as shown below. Ranger Station A is 6 miles directly west of Ranger Station B. Ranger Station A is directly south of Site C. That's telling us this is a right angle here. The entire region is flat and level. On a map, the angle formed at Ranger Station B by drawing straight lines from B to C and to A measures 57 degrees. About how many miles away from Site C is the closer of the two ranger stations? They don't tell you what you're looking for. They're saying the closer one. But we know among these two lines, the closer one will never be the hypotenuse. Why not? Because the hypotenuse is the longest side of any right triangle. So we know we are looking for this, the distance between C and A, this leg over here. So Let's go ahead and mark that with the universal variable x. So now, lest we forget, let's write down what we always have to write down. SOH CAH TOA, right? And our reference angle is 57. Let's write down the sides they give us. Well, we know we have this side. It's touching it, and it's a leg, therefore it is the adjacent side. And this over here, well, it's not a hypotenuse, and it's not touching the angle, therefore it is the opposite side. We are dealing with O and A. What's the only trig function with O and A? I believe it is tangent, TOA. So we know that the tangent of any angle is going to be the opposite divided by the adjacent side. So let's go ahead and write this down like a trig equation. If tan equals opposite over adjacent, well then the tangent of 57 is the opposite side, which we decided was x, over the adjacent side, which we decided is 6. Tan 57 equals x over 6, but we're actually solving for x, so this is not good enough. What we have to do now is isolate x by multiplying both sides by 6. This cancels out, the 6 is over here, and we're left with x equaling 6 times the tangent of 57. That's exactly what K says. Excellent. For our last problem, I have chosen number 16 from section 3 of the SAT. This is non-calculator, but grid in, no multiple choice. This can get a little bit tricky, but let's check it out. As always, let's write down the thing we've agreed to always write down, SOH CAH TOA. And now let's read this question. In the right triangle ABC above, BC equals 8. If the cosine of x is root 3 over 2, yikes, what is the length of AB? So we know they're talking about cosine. Let's focus on this CAH, and before anything else, let's just write down the cosine of any angle equals the adjacent over the hypotenuse. Now don't forget, a trig function is not a value. A trig function is a ratio. This is how we're going to find out the answer to this question. If the cosine of x is root 3 over 2, what is the length of AB? Well, unfortunately, that's not going to help us right away because the cosine is the adjacent over the hypotenuse. And well, AB is actually the opposite side, not part of this. So it looks like this is going to be a two-parter. We have to find this side first. Let's label it B. So if we know the cosine of x is root 3 over 2, let's go ahead and write that down. Cosine x equals root 3 over 2. We also know that according to this function right here, the cosine of x equals the adjacent side, or B, over the hypotenuse, or 8. Well, since these two are both the cosine of x, they have to equal each other. Let's write that down. Root 3 over 2 equals B over 8. Let's go ahead and cross multiply. 2 times B is 2B. 8 times root 3, well, it's just going to be 8 times root 3. And then, of course, if we want to isolate B, let's go ahead and divide both sides by 2. This cancels out, and B is going to be 8 root 3 over 2. We can reduce the 8 and the 2 to 4 and 1. B is 4 times root 3. Do not be worried about that root. I promise it's going to go away eventually. We know this side is 4 root 3. And so let's go ahead and label the side we want A. That is what we need. Now, if we have one leg that is 4 root 3, one leg that is unknown, and one hypotenuse that is 8, well, what can we do to solve for this unknown leg? Again, we turn to the Pythagorean theorem, where a squared plus b squared, each leg squared and added, equals the square of the hypotenuse, or c squared. Let's go ahead and plug this in. We know that a is unknown, that's a squared. b is going to be 4 times root 3. Let's be careful and use our parentheses. Squared equals c squared, which is 8 squared. So here's where it gets a little bit tricky. Let's keep going. We know that a squared plus 4 root 3 squared. What is 4 root 3 squared? Well, we squared both parts of it. 4 squared is going to be 16, and root 3 squared is going to be, well, root 9, or 3. So that's going to be 16 times 3. And of course, 8 squared is going to be 64. Let's keep doing some math. We're going to say that a squared plus 16 times 3. 16 times 3, let's actually do this out here. 3 times 6 is 8, carry the 1. 3 times 1 is 3, plus 1 is 48. That's 48 equals 64. Let's go ahead and subtract 48 from both sides. And we have a squared equaling, let's subtract here, that's going to be 6, turn this into a 5. That's 16. A squared is 16, a nice perfect square. We can root both sides, and we now know that a equals 4. And of course, if we go back to the question, they're asking for the length of AB, which we have labeled as lowercase a. The answer is 4. All right, I'd like to thank you all for joining. This has been a real pleasure. I'll ask you again to please subscribe to the channel and hit the like button. I will see you guys next week with some more math videos just for you.